Welcome to our topic on splay trees. So it's trees, obviously. It's also a binary search tree, but it's a very ugly binary search tree. It is very much not balanced, or non-balanced as it says there in the notes. And the reason is because the focus of this particular data structure, which actually has a lot of applications, is focused on finding the most frequently searched items that are in the tree fast. So what that means is that as we're building things up in the tree, it's going to end up being a BST, but those items that are at the very top are the ones that you're usually looking for over and over again, and I'll go over applications here in a moment. Now, by the way, your splay tree is not going to look as pretty as this, but I'm trying to make sure you understand it is a BST, so there is going to be a certain order because we still need to find things in it. But those items at the very top, again, are going to be the ones that we searched for the most. Now, there's going to be a lot of on averages here that I'm about to show and get highlighted right now. Is that on average, our overall speed for this is log of n. Now, again, that's on average, meaning it could be better and it could be worse, but as you see a little bit, it should be actually better than log of n, and that's good news for us because, again, we're worried about speed. So the data structure, this particular data structure is used for searching repeatedly used items, or items that you know that you're going to come to often. If you have a structure that you basically got a one-to-one ratio on every single node that you're going to end up searching for, this isn't it. This is for ones that, well, I'll go into applications here in a minute, but pretend you keep going to the same website over and over again and you have a list, drop-down list. You know, it's that one keeps being pulled up. That's what this data structure is about. So very particular algorithm or overall structure that you want for this data structure. So you're going to see this in much more detail, but I wanted to show you if we started adding data to it, because you have to eventually add data to it. What's going to happen is that first you're given a binary search tree. When you start adding to it, like in this we add 36 to it here, 36 actually had a location that's showing up. That's really where it should have been first, and that's where it gets placed first. Then we do a rotation to make sure that 36 is actually at the top, because that might become our newest node that we're going to be looking at very often. So the building of this is the interesting part and the slow part of it. After the data structure is actually built and we start doing a lot of searches and stuff like that, it should start arranging itself like this one here, where notice there's a lot of data. Those three items that you see highlighted in the notes is what we're being looked at the most. And notice they're towards the top of the tree. That should make sense because that means that our overall search for those items is going to be even faster than if they were buried deep within the tree.